Now I am going to discuss you about Thevenin's theorem. What actually Thevenin's theorem do? Okay, here this is any complex circuit. Complex means a huge network is there. That huge network can be replaced by simple. Okay, can be replaced by simple voltage source in series with the Thevenin's equivalent resistance. Okay, a large network will be there here. The large complex network can be replaced by voltage source in series with Thevenin's resistance. Okay, so how these Thevenin's resistance and Thevenin's voltage can be calculated, we will see with one example. Before going to that, let us see the statements once again. Okay, it is a linear bilateral network. Linear means which obeys Ohm's law like that. That means as voltage increases, current also increases, which is a graph which follows passing through the origin. What about bilateral? Bilateral means here we know resistor. For resistor, we can send current either this direction or this direction. So the resistance property is not going to affect. Okay, resistor will be resistor itself. Whereas if we see the diode case, if I send the current direction in this direction, it is becoming like short circuit. And if the diode, for that the diode, if I send the direction of current in reverse, that means in reverse bias, it is a open circuit. That means the behavior is going to change. So it is not a bilateral. So bilateral means here resistor comes picture. And a two terminal network. So it is a linear two terminal bilateral two terminal network can be replaced by equivalent network, that is consisting of VTH and RTH. Okay, very simple circuit. It is a large circuit. This is a black box. In this black box consisting of so many circuits, those circuits simply we are replacing with single voltage source and single resistance. And this load is a either variable or fixed. Okay, so it may be varying or fixed. So this total, that means here how the load is, how the load we will determine. In the question they will ask find current through some x load. Okay, we have to find that load. Okay, we have to find the current through that x, or we can find the voltage across the x terminal. So here how VTH is calculated. VTH is calculated whenever the circuit is there, the complex circuit is there. Now in that complex circuit load is removed first. When the load is removed, you will going to get the voltage. Okay, at open circuit also we will get the some voltage. No, that voltage is nothing but the Thevenin's voltage. Okay, VTH. And what about the resistance? So when the load is removed, you are having the complex network. No, that complex network, in that complex network all the voltage sources and current sources, voltage sources are there means simply replace it by short circuit. If current source is there, simply replace it by open circuit. Then you will be having only resistors. So you just look over from open circuit case and you just find the equivalent resistance by using series parallel combination, so that you are going to get RTH value. Okay, so this is the actual network we are having. The modified network will be very simple. It is RTH will be in series with RTH will be series with the RL circuit. This is the VTH voltage source. Okay, this is the VTH and this is the RTH and this is the RL load. Okay, this will be RL load. This is the modified circuit. Okay, so let us see the modified circuit once again. Let me clear all these things. So here this is the modified circuit. How this modified circuit is there? Okay, in this we need to follow some steps. In order to get this modified circuit, the following steps must be. Okay, so load is there. No, remove that load. Steps you need to follow is removing the load. Step 2 is you have to find the voltage across the open terminals. When load is removed, you have to find VTH and also you have to find RTH. Just now I said, okay, you just replace voltage source as short circuit and current source as open circuit. And after finding the VTH and RTH, connect RL to the Thevenin's equivalent circuit, and then find the response. What will be the response here? This is a simple circuit, no? So you can find the current through this one, no? The current through the load. What is the current through the load? Simply we can give the formula by I is equal to just V is equal to I, or no? I is equal to V by R. Here V is VTH. V is VTH and R. How these two are connected? So this load is the RL. Suppose if I consider load as RL, how these two are connected? They are connected in series. So simply I can write by RTH plus RL. So we can get the value of current. Now let us find the circuit by considering this example. Okay, let me clear all. Here find current through 160 ohms in the following circuit. Okay, current through 160 ohms in the following circuit. Let me take the pen. Okay, here current through 160 ohms. So this 160 ohms is nothing but this will be RL. Okay, this will be the RL. So what is the step one you need to do? Step one, you have to remove the RL. So I have removed RL. That is a step one. So this is the step one. What is step two? We have to find VTH at the open terminals. So we have to find VTH here. Okay, VTH, this is the circuit. Okay, you have to find VTH. Before finding VTH, what is the current? Because we don't know the current here, no? So I want the VTH across this. Actually 100 volts is there. The 100 volts will be appear, no? But the thing is there is some resistor. If there is no resistor means this 100 volts will be appearing at this open circuit. But because of this 20 ohms, there is some drop across this resistor. Because of that, some voltage drop, the remaining voltage will be appeared across this VTH terminal. So in order to find that VTH, we should know the current. Okay, so when I open these terminals, I have opened this terminal means here these two, because of this 100 volts current will be flowing. We know that current flows from higher potential to lower potential. That means plus to again minus. So because of these sources, current will be flowing in this direction. Let us consider that current I here. So in order to find that I am applying mesh analysis or loop analysis. So we know that if current is entering from negative to positive, here likewise the current is entering, no, in this direction. So negative to positive means positive. Then the resistors are there, no, voltage consuming elements, nothing but positive and negative. Voltage drops always indicated with minus. So it is, what is the voltage across here? 20 ohms. That is I, current is I. We don't know the value of voltage, no. Directly I am replacing V by, V can be replaced by I into R. So what is I? I is I itself and R is 20. Similarly, the same current will be flowing since it is a series circuit. Okay, same current will be flowing minus 20 into I. Then here see the direction of current. This is plus to minus. So minus. So entering from plus means it is minus 70 is equal to 0. So I will get 100 minus 70 as 30, minus 20 is minus 40. If I shift right side, it is plus 40 I. So from this I will get the value of current I, that is 0.75 amperes. After getting this value, I want to know the voltage at these open terminals. So I am connecting the VTH here. Okay, I'm just writing the VTH. Open circuit also we are getting some voltage, no? So here when you connect some voltage source like this, you will be getting the two sources, sorry, two loops. Okay, loop 1 or loop 2. So any loop, you can go with any loop, you will get the some values. Okay, so based I'm doing the two loop equations. Let us find the loop 1 equation, and we know that current through this, already we have determined current through this branch. Okay, so this method. So loop 1, if I consider minus 200 is plus 100, minus 200 is plus 100, this is drop, that is minus 20 into I, because voltage I am writing, no, current into voltage is, current into resistor is voltage, minus 20 I. Then current is entering from positive to negative means minus VTH is equal to 0. From this I am going to get, already I got, I know 0.75. From this I am going to get 100 minus 15 is 85 volts, that is VTH. Okay, 85 volts. Let us go with the loop 2. I am taking the clockwise directions only. So plus minus is there means minus 20i, plus minus is there means minus 70, and here minus plus is there, no, already I have assumed, no, minus plus is there means current is entering from negative to positive means it is plus VTH. Okay, plus VTH is equal to 0. Minus 20i minus 70 plus VTH. So this value is minus 15 and minus 70, which is minus 85, is equal to minus VTH. Minus minus gets cancelled, it is 85 volts. So we can do any method, you will get the same value. Okay, this is the voltage, Thevenin's voltage. We got step 2. Step 1 is load is removed. Step 2 is we got RVTH. Now we have to go with step 3. What is step 3? Step 3 is we need to find the equivalent resistance. Okay, let us find the RTH. So previously what I have assumed, I have assumed that these are the previous circuit, because of the voltage sources, when current is flowing like this, I got that two resistors are in series. Whereas when I closed this, when I replaced that voltage sources by short circuit, we know that in order to find RTH, if voltage source is there, we have to make short circuit. That's why two short circuits here. 100 volts is replaced by short circuit, and this 70 volts is also replaced by short circuit. If current source are there means open circuited. So when it is short circuited, what is the current path, how the current will be flowing? Okay, what I am doing is, inside, previously the arms are inside. Now what I am doing is I am stretching out the arms. If I stretch out the arms, suppose if I stretch out the arms like this resistor I can drag here, no, I can drag like this. Okay, this is the arm which is stretched out, and this resistor also I can drag like this when it is stretched. Okay, this is the circuit I am going to get, the resistance. Okay, like this I am going to get. If I apply some voltage source, let us assume, this is the assumption I made, if I apply some voltage source, current will be flowing in this. Because of this voltage, current will be flowing, so currents are divided, so current division is taking place. This is not a series circuit, it is a parallel circuit, because current division will be taking place if I assume the voltage, if I apply the voltage at these points. Okay, so that's why these two are in parallel. If they are in parallel, what you have to do? Product by sum, that is R1 R2 by R1 plus R2. 20 into 20 by 20 plus 20, which is 400 by 40, 10 ohms. Then we got RTH and we got VTH. What you have to do? RL is removed in the step 1, which is permanent, temporarily, no, that RL we need to connect to the Thevenin's equivalent circuit. What is Thevenin's equivalent circuit? Single voltage source in series with Thevenin's resistance. So what we got? VTH is 85 volts and RTH is 10 ohms. So this is the circuit we got. Connect RL. Now you have to find the current through RL. Now in the question they asked what is current through RL. How you will find? Current through RL can be determined by very simple method, that is I is equal to V by R. Just I am applying Ohm's law. Let us take that I is flowing in this. Here whatever the current is flowing through 10 ohms, the same current will be flowing through 160, because they are connected in series. So I is equal to V by R. V is VTH and R is, they are connected in series means these two resistors are added up, that is RTH plus RL. What is VTH? VTH is 85 and RTH is 10 and RL is 160. 85 by 170. 85 ones are, and it is 85 twos are. 1 by 2 value is 0.5 amperes. Okay, if any doubts are there, you can ask me through the messages. Okay, thank you. Keep sharing and subscribe my channel. Thank you.